Welcome to you all friends. I am Professor Mohammad Tariq, working in the Department of Economics, AMU Aligarh. In the last few lectures, we talk about the rate of return on different assets. We discussed two models, particularly one model which was related to, which is called as this mean variance covariance model. Mean variance covariance model. The another one, capital asset pricing market, we talked about. This is also based on this mean variance covariance, this capital asset pricing model. Now the basic problem with this mean variance theory or mean variance pricing model is this, that we have to find out a number of parameters, a large number of parameters we have to find out. The biggest difficulty, and normally the data on these parameters are not available, or it is, even if it is available, it is not easily available. Now, number two, no logical deductions about the parameters can be done. So the logical deductions are also not possible. That is clear. We had gone for this mathematical statistical derivation. So this is the problem. Now the basic question is there any alternative to this? The answer is yes, an alternative to this has been provided by the econometricians, and this is in terms of two analysis. One is known as factor model analysis. Number two is your APT, arbitrage pricing theory. Arbitrage pricing theory, APT. Second one is arbitrage pricing theory. So that is there. These two models are there. If we look into the mean variance hypothesis, what do you find? Mean variance hypothesis, we need n mean for assets, n variances, and n into n minus 1 by 2 covariances. N into n minus 2 covariances. We need this one. So what is this? In total, we need 2n plus n into n minus 1 by 2 parameters to be estimated. So if there are 1000 stocks in the market registered in the stock exchange, we need, if you substitute n is equal to 1000, we need 1500, we need 5,1500 parameters to be estimated, which is quite large. So this complicates this mean variance analysis when capital asset pricing model. So the common stocks which are listed in the stock exchange, let us first talk about this factor model analysis. The common stocks which are listed in the exchange, it depends upon a number of factors. These factors could be the capitalization of market. This could be the GNP, gross national product, the country. This could be the employment level. Etc. There could be many factors. So this rate of return might depend upon only one factor or more than one factor. So under this we study this the simple single factor model analysis. We'll talk about single factor model analysis, and then we talk about multi-factor model analysis. We'll be talking about two-factor model analysis. Whatsoever is true for two factors will be true for many factors, 3, 4, 5, 6, something like this. So we have single factor model analysis and the two factor model analysis. Let us first discuss about the single factor model analysis. What is single factor model? The single factor model, suppose there are n assets where I is equal to 1, 2, 3 up to n. Okay? So there is a single factor, there is a single factor. Let that factor, the first alphabet of factor is f, let that be denoted by f. So there is a single factor f on which the return depends. Clear? And this f is nothing but this f is a random quantity. So the relationship between Ri, this can be written as Ri is equal to Ai plus Bif plus Ei. So this is the relationship. What is this? Ai is the intercept term. This is Bi is called as factor loading. Called as factor loading means if there is one unit change in f, what will be its impact on Ri? And this Ei is the error term. This is a stochastic error term and it follows certain assumptions, a stochastic error term. What are those assumptions? The assumptions are expected value of Ei is equal to, these are the standardized assumptions, expected value of, the mean value of Ei is equal to 0. This means Ei, Ej, the two error terms are not correlated. This if they are correlated, this is called as the problem of autocorrelation. So we assume there is no autocorrelation problem, and this expected value of f minus f dash into Ei, this is also equal to 0. So we assume this one, and variance of Ei is known. Variance of Ei, the variance of Ei is known, and this is equal to sigma Ei square. This is known. These are the assumption. So now if we have the data on Ri and f, R and F, we have the data on R and F. You can have these data points or some, these are the data. And on this data points, a straight line can be fitted. This straight line should be fitted in such a way that fitting a straight line fitting of a straight line in such a way that these terms, the distance between the actual value and the fitted line, the gap between actual value and fitted line, clear? These are called as the error terms, EI. So any point above this EI is positive, any point below this EI is negative, in such a way that this sigma EI, this is equal to 0. This is the one of the assumption that expected value of EI is equal to 0. Clear? This shows this fitting. Now suppose this fitting, this is your AI and the slope is given by BI. So if we fit this data for each and every asset, I, this is being fitted, we get different values for AI, we get different values for AI and BI. We get different values for AI and BI. Clear? So the different values for AI and BI is being obtained. Clear? Now, this AI is intercept and BI is factor loading that I have already explained to you. And what is the meaning of this factor loading? This factor loading, this says that this shows the impact of this F factor on RI. Now we get different AI and BI for different value assets or for different sets of data, different types of data, set for different sets of data. Whether we have daily data of the stock exchange, we have monthly data, the stock exchange, or if we have yearly data or quarterly data in the stock exchange. It is on the basis of the availability of the sets of data that also that the value of AI and BI differs. Now in the single factor model where we talked about this RI, this is equal to AI plus BI into F. Now we calculate the mean value for this RI bar, this is equal to AI plus BI F bar. BI bar. So this is the mean that we have calculated. Now the variance sigma I square is equal to BI square sigma F square plus sigma EI square. Now the third thing is covariance Bij sigma ij is equal to Bj into sigma F square, where Bi is equal to covariance between Ri F divided by sigma F square. Now compare this model, single factor model, with that of mean variance model. In the mean variance model, we were supposed to estimate, find out 2n plus n into n minus 1, 2 parameters. Here the parameters to be estimated are, here one factor model, the parameters to be estimated are AIs, BIs, sigma F square, sigma EI square, and F bar. These are the parameters to be estimated, which comes out to be nothing but 3n plus 2 parameters. So If you compare this with these two, we find that one factor model is much simplified, is much simplified one factor model is a much simplified one. So this is the situation when we consider that this rate of return on asset depends upon one factor only. But this is not the reality. The rate of interest may not depend upon one factor model. And if we try to calculate by taking into consideration only one factor, like Ri is equal to Ai plus Bi F plus Ei, so there will be, if this rate of return depends upon more than one factor, and we estimate by taking into consideration only one factor, so this will simply be called as the misspecification of the model. And in this situation, the other factor impact of other factor might be seen in EI. So the value of EI would be very large. The value of EI would be very large in this situation. So an improvement over one factor model is the two factor model. And whatsoever is true for two factor model will be true for multi-factor model as well. This will be true for multi-factor model. So under this two factor model, what it will be? It will be Ri will be equal to Ai plus B1i F1 plus B2i F2 plus Ei. Two factor model. Now let me rewrite this two factor again. Two factor model. Ri is equal to Ai plus B1i F1 plus B2i F2 plus Ei. This is a two factor model. Now this model, the general assumption, expected value of Ei, expected value of Eij, expected value of F1 minus F1 bar into Ei, and expected value of F2 minus F2 bar into Ei. This is equal to 0. But it does not assume that F1 and F2, they are not correlated. They might be correlated because the two economic factors might be correlated, which is affecting the rate of return. This may be due to this covariance between the two factors. Now here the parameters to be estimated. Let us talk about this. The mean value Ri bar, this will be equal to Ai plus B1i F1 bar plus B2i F2 bar. Sigma Ei, this is equal to 0. Clear? Now the covariance and variance, covariance, this covariance between Ri and Rj. If Ri is equal to j, then the same term becomes the variance one. So if we write down this, the formula for covariance between Ri and Rj, this will be equal to expected value of Ri minus Ri bar into expected value of into Rj minus Rj bar, and this finally we can write down this is equal to B1I B1j sigma Fi square plus B1I B2j plus B2I B1j into covariance between F1 and F2 plus B2I B2j sigma Fj square for I is not equal to j. This is equal to B1I square sigma F1 Fi square plus twice B1I B2I covariance between F1 F2 plus B2I F2 square for I is equal to j. So this is now covariance between Ri and F1, covariance between Ri and F1, this is equal to B1I F1 square plus B2I sigma F1 F2, and covariance between Ri and F2 is equal to B1I sigma F1 F2 plus B2I F2 square sigma F2 square, so sigma F1 square. So here also, if you compare, even if the two-factor models, in two-factor models we have to estimate this one, this one, this one, this one, estimate the values for A i's, B1 i's, B2 i's, like this sigma F1 square, sigma F2 square, similar. All these values which we are supposed to estimate, this is much smaller than n into 2n plus n into n minus 1 by 2 under mean variance model. Under mean variance model. So, what is this? It is still simpler, despite it is a bit more complicated than one factor model, but it is still very simpler than variance covariance analysis. Clear? So this is about the factor model, one factor or the two factor model. Now the question is whether we are in a position to correlate the CAPM, capital asset pricing market, with one factor model with a single factor. Can CAPM be expressed in terms of single factor model, which is much simpler? So the answer to this question is yes, we can express. The CAPM can be expressed in terms of a single factor model, where we try to find out the relationship between Ri and Rm. What the basic equation of this CAPM model is, Ri is equal to beta I into Rm minus Rf. This is your beta factor. We talk about, we write down either beta I or beta. And sorry, this is the relationship between this beta I into Rm. Try to find out the relationship between this and this, or Ri being a function of this Rm. Now let us subtract this Rf fixed factor from this both Ri and Rm. So this Ri can be written as Ri minus Rf and Rm minus Rf. This is excess return on ith asset, and this is excess return on market asset. So here this Ri, this can be written as alpha I plus b, oh sorry, can write down Ri minus Rf. This is equal to alpha I plus beta I Rm minus Rf plus Ei. So here the relationship is being established between the excess return on ith asset. This is the return on fixed asset. What is Rf? Rf is return on fixed asset. So this Ri minus Rf is the excess return on ith asset. This is the excess return on market asset. So this is like this. Here again we assume that expected value of Ei is equal to 0. Expected value of Ei Rm, this is equal to 0. Expected value of Ei Eg autocorrelation, the mean value of error term is equal to 0. The error term is not related to this market asset return, and there is no problem of autocorrelation. Clear? And it's on the basis of this that we are in a position to draw a line. So this is the relationship between this and this. This can be drawn, shown with the help of one diagram. On this axis we take Rm minus Rf. On this axis we take Ri minus Rf, and we draw a line, a straight line. And what is this? This is your alpha I. This is fitted to a set of points showing this in such a way that this mean value of Ei is equal to 0, means the error terms. What is this? These are the error terms. These are the E's. The positive Ei, and this is your negative E's. And this line we call it as the characteristics line, or the characteristic. This equation we call this as characteristics equation, and this line we call it as, this line is your characteristic line. We call this as the characteristic line. So this shows the relationship between these two, to the scatter point. Now the expected rate of value of this equation, if we try to calculate the mean value of return, so expected value is nothing but mean value. Expected value of the equation is, what is this? This is Ri bar minus Rf, which is equal to alpha I plus beta I Rm bar minus Rf. Okay, so here alpha CAPM predicts that. Now, what is the difference between this equation and CAPM? Capital asset pricing market. The CAPM assumes that alpha I is equal to 0. So, what is this? The equation which we had derived in the last lecture. This is equal to beta I into Rm bar minus Rf. But here we have this term alpha I, which may be 0, which may not be 0. So, what we can infer from this, that this single factor model, this is nothing but the generalized form of CAPM, capital asset pricing model, where alpha I is not equal to 0. It's non-zero. So this alpha is, if it is not equal to 0, this could be either positive, or this alpha I could be negative. It could be either positive or negative. If alpha is positive, that means that the assets are performing better than it should. Means if alpha is positive, if alpha I is write down this equation once again. Ri bar minus Rf, which is alpha I plus beta I into Rn bar minus Rf. If alpha I is positive, then assets performing better than what it should. If alpha I is negative, then just assets performing worse than what it should. Clear? The simple meaning. Now, the difference between CAPM model and CAPM and single factor model is due to the covariance factor. Due to the covariance, because of covariance matrix is not equivalent. In both the model, the covariance matrix is not the same. So this is CAPM and single factor model. The difference is because of the covariance matrix. So this is all about the single factor and two factor model.